Hi again. This is the second video to section 14, factoring quadratics. The first video, I showed you the factoring by grouping technique. And in this video, I'm going to show you the T-chart method. So I'm going to do the same two examples. This way you can do a direct comparison between the two videos and see which one works best for you. So we're starting off with f of x equals 3x squared plus 2x minus 1. Same as we did in the previous video, and our task is going to be to factor this. We start off with the same first steps. So the first step is to factor out a GCF if possible. In this example, we have 3x squared plus 2x minus 1. Those terms don't have any common factors, and so we can skip step number 1. Step number 2, once you make sure that this is a quadratic, because you can't go through these steps unless you're talking about a quadratic, which is a high power of 2 on the variable. So once you verify that you're dealing with a quadratic, then you're going to multiply AC. And that means you need to be able to identify A, B, and C. So let's compare this to the general form of a quadratic, which is ax squared plus bx plus c. A is always our leading coefficient. B is always paired with x. And c is always our constant term. So in this particular problem, if I'm multiplying AC, A is 3 and C is -1. So 3 times -1 is -3. Step number 3 is when I ask myself the question, what multiplies to get AC, but adds to get B? If I put numbers to that in this particular problem, it's what multiplies to get -3, but adds to get 2. So we want to make our little multiplication tree for -3. What multiplies to get us -3, but adds to get us +2, that combination is going to be a +3 and a -1. Okay, this is where it becomes a different strategy. We're now using the T-chart strategy. Step number 4 is to create a T-chart, which is simply just a plus sign, okay? Create a T-chart and put the leading term of the quadratic in the top 2 spots and the numbers from step 3 paired with x in the bottom 2 spots. So in this problem, my leading term is 3x squared. So 3x squared goes in the top 2 spots of the T-chart. My 2 numbers that I came up with paired with x are going to go in the bottom 2 spots of the T-chart. So this is how I would arrange my T-chart. In general notation, you're talking about ax squared always going in the top 2 spots, and then some number paired with x and then some number paired with x coming from step number 3. So coming from that step right there. So the t-chart is always going to be set up this way. Step number 5 of the t-chart technique is to look at the columns of the t-chart as if they were fractions and simplify. So our t-chart had 3x squareds in the top 2 spots. It had 3x and negative 1x in the bottom 2 spots. I'm going to branch them out sideways. I'm going to look at this as one fraction, and I'm going to look at this as one fraction. Can these be simplified? Sure, x and x squared, one of those x's will go away, and 3 divided by 3 is 1. So this is going to simplify to 1x over 1. What about this? The x's will simplify. The numbers can't do anything, so this is going to simplify to 3x over negative 1. So you get your simplified fractions in step 5. Step 6 is pretty much your last step. The 2 simplified fractions become your terms of the factors. So in other words, this 1x over 1, that becomes 1x plus 1. That's your first parentheses. This 3x over negative 1, that becomes 3x minus 1 in your parentheses. And this is now your factored form of the original function. Now, if you wanted to double check that, if you wanted to verify that, you could distribute this and make sure that you get 3x squared plus 2x minus 1 back. So if we did that really quickly here and distributed, we would get 3x squared minus 1x plus 3x minus 1. And when we combine like terms, we would in fact get the original function back. So if you simplify the t-chart correctly, you will automatically get your 2 factors. So it works out pretty nicely. A lot of students like this technique because the answer just kind of falls out of it. So whatever technique makes the most sense to you, that's the one that I want you to go for. So the other problem that we did in the previous video was the function f of x equals negative 40x squared plus 34x minus 6. So let's do this one again. The first 3 steps are the same, so factor out a GCF if possible. And do so in such a way to make the leading term positive. Positive numbers are so much easier to work with, so the more we can turn things positive, the better. So in this example we saw in the previous video, these are all even, which means I could factor out a 2, and I can factor out a negative 2 because I want to get rid of that negative. So this is going to be f of x equals negative 2 parentheses 20x squared minus 17x plus 3. Step number 2, again, first make sure that you have a quadratic left. We do have a quadratic left because it's a high power of 2 on the variable. So next we multiply AC. If I compare this to ax squared plus bx plus c, I can identify that a is 20, b is negative 17, and c is 3. So when I multiply AC, I'm doing 20 times 3, which is 60. And then we ask ourselves that same question: what multiplies to get 60, but adds to get negative 17? So it has to multiply to give us 60, but add together to give us negative 17. That means I must be dealing with negative numbers if it has to add together to give me negative 17. So I can do some trials just like we did in the previous video. But we do know, again, from the previous video, because we already did this example, it will turn out to be negative 12 and negative 5 that will do the trick. This is going to help us fill in our t-chart. So again, step number 4 is to create a t-chart with the leading term of the quadratic in the top 2 spots, and the 2 numbers from step 3 paired with x in the bottom 2 spots. So in my t-chart, it would be 20x squared going in the top 2 spots. It would be negative 12x and negative 5x in the bottom 2 spots. Step number 5 would be to look at each column of the chart and simplify as if they were fractions. So, copying the chart one more time, I have 20x squared on top. I have negative 12x and negative 5x on the bottom. I'm going to simplify branching out sideways. If I simplify 20x squared and negative 12x, I want to know what they both have in common. The x's will certainly cancel out. 20 and negative 12 are both divisible by 4. So if I do that, I'm going to wind up with 5x over negative 3 if I simplify that fraction. And on this side, the x's will cancel out. 20 and negative 5 are both divisible by 5. So if I do that, I would get 4x over negative 1. And then step number 6 is that these fractions become your factors. So the quote-unquote fractions become the factors. And so I would have f of x equals, don't forget about your GCF that you took out in the beginning. So this negative 2 was your GCF from the beginning. I would have 5x minus 3, and I would have 4x minus 1 as my 2 factors. And then if you really wanted to, you could go back and redistribute this to make sure that you get the original quadratic or the original polynomial back. So this is your T-chart method. If you like this one better, you can use this one. If you like factoring by grouping better, you can use factoring by grouping. But I think these are the two most straightforward ways that I could show you in videos. So my next videos will be a combination of these different techniques. So if you have any questions, as always, let me know, and have a great day.